Hello guys, welcome to my YouTube channel. In this video, I will talk about the most important step in any machine learning approach. So that is to split the data into different sets so that we can measure the performance of our trained model. Okay. So let's say we have whole data. Okay. So let me create a block. So this is our whole data. Okay. Let's say we have around 10,000 records. Okay, so we have 10,000 records and we want to train our machine learning model on this particular data set. So let's say we are dealing with regression problem. This approach always applies to any kind of training machine learning model, that is if you are dealing with regression or it may be classification. Okay, so it do not restrict this approach to only regression problems, so you can apply the same approach to classification as well. So let's say we have this particular data. We want to train a machine learning model to predict our target variable. Okay, so we will have x1, x2, x3, x4 up to xn, and then finally we will have our target variable y, correct? And we will have our number of training examples. So in this case, we have 10,000. Okay, so let's say what happens if we use all these 10,000 records to train our machine learning model? So let's say we train the model. Okay, we provide this input data to our ML model and it will be trained on. Okay, so once it is trained, we will get our model metrics. So it can be regression. If it's regression, we will take our R2 score or mean squared error, mean absolute error, or such stuff. Or else, if it's a classification problem, we will basically check the accuracy and confusion metrics. Okay, there are many other ways to measure the classification model performance. Now we have checked the model performance on your trained model, but how sure are you that this particular model will work in the same way on unseen data? Okay, let's say we have achieved very good R2 score of 0.98. Let's say we have good data and we have trained our model pretty well on this whole 10,000 data set, and we have achieved our R2 score as 0.98, which is really a very good score, and even adjusted score R square is coming at around 0.97 or 96. Okay, which is very good. But how sure are we that this model will produce the same result on our unseen data? Okay, so of course, since we have trained our model, there should be a reason, right? We should deploy it in a production, right? Or we have to make use of this model on some data which will be coming in our future case scenarios. Okay, so how sure are we that the model will produce the same effect on unseen data? Okay, so how can we make sure while we train the model? So we are not sure at the moment, correct? Because we have utilized the whole available data set. So in order to avoid this particular issue, what we do, so let's say we have a data set. Okay, I will again create the block. So this is my whole data set. Okay, and let's say I am splitting this data. Let's say I am consuming around 70 to 80% of the available data for my training. Okay, this is my training data set, and this is my test data set. Okay, test data set. So why we need to split this data? Okay, as I have explained an issue earlier, right? What happens if we make use of whole available data set just to train the model? We will be left with no data in order to test the model performance on unseen data set. So to avoid that issue, we will split the given data set into two parts mainly. Okay, actually we'll split into three parts, but just consider for now we are splitting it into two parts: training and test data set. So we will train the model on this particular subset of the whole data. We will train the model. Okay, and then we will check the train the model performance on test data. Train the model performance. Okay. Okay. So just keep this in mind. Before proceeding further, I want to tell you a general basic approach for any machine learning problem. Okay, so we will be given with the data. Okay, so let me just, we will be given with the data. Now the first step will be to pre-process. We will pre-process this data set. Okay, once we pre-process the data set, we will do some feature engineering. Okay, feature engineering. Then we will do our feature selection. So what features we will be making use in our machine learning model to train on this particular data set. Okay, feature selection, and then we will train our model. Okay, train model. Once we train the model, we will also need to fine tune our model. Okay, so once we train the model, we will fine tune the model. Fine tune the model. So how do we fine tune it? So we will make use of hyperparameter tuning. Okay, hyperparameter tuning. Once we are done with the fine tuning, we will test our model performance. Test model performance. Right? So now to train the model, we have our training data, right? We have our training data, correct? And to test our model, we have our test data. But how do we fine tune our model? On what basis we will fine tune the model? So in order to fine tune the model, we will take the subset within the training data as a validation data set. Okay, so let's say we have a data set now. So this is my data set. Okay, and this is my whole 10,000 records. Okay, now initially I am splitting it into train and test. Okay, this is my 80% of the data into train and 20% into test data. Okay, now we have to make some room for validating the model training at each step in order to fine tune the model. Okay, so what do we mean by fine tuning? So let's say I have this training data, right? So this particular training data, this is the training data, train data, which is of 80% of the whole given data set. So what I will do, I will keep aside some 20% of the data. 20% of the data as my validation set. So what do we do with this? So let's say and then this remaining 60% of this 80% will be my training data. So what's happening here? Initially I had 10,000 records. Okay, I split it into two things, right? So 8,000 into initial training set and 2,000 into test set, right? Now what I did, I again split this 8,000 into two sets, right? 20%, that is 1600 records as my validation data, and remaining 6400 records as my actual training data. Okay, so what I will do with this particular validation data? So let's say I am training the model using 6400 records. Okay, 6400 records. I am training my model. Training the model. So once I am done with training the model, the output will be some metrics, right? Metrics. Based on the problem type, regression or classification, this metrics will differ. So once I have the output from the training model, I will apply this model. I will apply this model on my validation data. Okay, and then check the metrics, how it is performing. Okay, So this is based on this particular matrix. Let's say if this is giving me somewhere around 0.98 R2 score or R square score, and let's say this is giving me some 0.7 or 0.5, which is very low. It is doing well on the training data set but not doing well on the validation data set, right? So this is actually the case of overfitting. We say our model is overfitting. So I will make a separate video on model overfitting and model bias, right? So just say this is our matrix right now. So now that we have this particular matrix, we will make some changes to our hyperparameters. Okay, we will tune the model hyperparameters based on the output that we receive on the matrix and compare the matrix between training and validation data. Once we do the hyperparameter tuning, we will again train the model on the 6400 datasets, okay, records, and then check the matrix. Since we have done the hyperparameter tuning, we expect the matrix to differ slightly. Okay, so our main aim is to avoid this particular difference here, right? So we do not want our model to underperform on our validation dataset. Okay, so now what we have done the hyperparameter tuning. Let's say we have achieved some decent metrics with train data. Let's say we are achieving somewhere around 0.92, and also on validation data, let's say we are achieving our R2 score nearly 0.90 or 0.91. Okay, so this is not much of a difference. We can accept this as our fine-tuned model. Okay, now we have this fine-tuned model. By changing some parameters, tuning the parameters, we have our model, ML model ready, right? We have this is our fine-tuned ML model. Okay, fine-tuned ML model. Now that we have fine-tuned ML model, we will give test data as input to it. Okay, test data as input to it. This is still unseen by the model, right? Unseen data. Model has not seen this particular data in this whole process of training and fine-tuning the machine learning model, right? So this is a separate set. So this is our 20% of 10,000 records initially that we kept aside, that is 2,000 records, correct? Now we pass this test data to the ML model and then check the performance. Okay, so how do we check the performance? Again, we will make use of some particular metrics. So now we will check this matrix. So this matrix, the output of the matrix should be similar to what we achieved in training and validation. We want this kind of result. Okay, the model should be performing equally well on unseen data as well. Okay, so this is why we split the data into 3 separate sets, that is training set, validation set, and test set. Okay, now there is something called as cross validation. So cross validation, and let's say we are giving some number 4. So we want to do 4 times cross validation on our given data. Okay, so what do we mean by this? Let's say we have I am only considering the training data now. Okay, this is my 80%, right? 80% of my 10,000 records, correct? So this is around 8,000 records. Now in this, I am keeping cross validation as 4, and at each cross validation I am making use of, let's say, 20% of the data. Okay, 20% of what data? 20% of training data, that is 8,000 records. So let's say when CV is equal to 1, the first cross validation, what will be done? The first 20% of this 8,000 records, that is this 20%, will be acting as validation, and this remaining 80% of this 8,000, that is 6,400 records, and this is 1,600 records. Okay, this will be acted as train data. Okay, this is when my cross validation set is making use of first time. So with this we will have some metrics, correct? So I will call it as matrix 1. Okay. Similarly, I will have my second cross validation. So second cross validation will also come from the same training data, right? So this time it will be a separate check. So it will be this 20% will be acting as validation, and this 20 and this 60. So this particular 80 will be acting as training data. And for this, we will have our separate matrix called as matrix. Let's name it as matrix 2 for our convenience. So like this, we will have up to CV is equal to 4. We can have 5, 6, 7, as many cross validation as we want. Okay. And let's say we are considering our last chunk of this 20%, okay, as my validation, and this will be training. Okay, for this particular thing I will have my matrix and I will name it as matrix 4. Okay, now with this help of cross validation, at the each cross validation step my validation and training data is getting altered. Okay, so this is a best way to train any machine learning model, making use of cross validation set, so that our model will be subjected to different types of data during the training itself. Okay, so this is called as variety in machine learning model terms. So we need variety of data. It needs to be changed at each step so that our model can be performing better on any unseen data, so that we can fine tune the any machine learning model at the given step. Okay, so what we do, we can take average of this all the metrics, average of all matrices, and then do our hyperparameter tuning. Okay, once we are done with hyperparameter tuning using cross validation set of 4, we will finally apply this model onto our test data. Okay, and then we will check the model performance. Okay, so totally how many sets, into how many sets we divide the data? We divide the data into 3 sets. Okay, so first is training, we split it into validation, and then we split it into test set. So test set will be kept aside. This will be also called as unseen data, right? This validation and train plays an important role in while training the machine learning model. This particular training data will be used for training the model, and this validation data set will be used for hyperparameter tuning. Okay, also called as model fine tuning. So once we are done with this, we will apply our fine tune model on test data to check the performance on unseen data set. So I will make a separate video on different types of cross validations that are available. So that will be explained in my upcoming videos later, sooner or later. Okay. So hope you guys understood why we need to split the given data set and how we need to split the data set and importance of this particular cross validation data split. Okay. So if you guys have any questions, please post it in comment sections. Till we see you in the next video. Happy learning. Bye bye.